Okay, I'm back. Sorry, this is number 6. So I'm going to find the definition, I'm going to use the definition of the derivative at a point to find the derivative at the point. And I want to find the derivative at 3. So f prime of 3 equals, the formula is the limit as x approaches our coordinate all over the original function minus the function when I plug in 3 all over x minus 3. That's what it's going to look like, the setup. And then I'm going to move over here a little bit. We now can plug in the function and what f of 3 actually equals. So the actual function is negative 3 over x minus 1 minus, I plug 3 into the function, I get negative 3 halves, so it's plus 3 halves all over x minus 3. Okay, so then I need to get common denominators in this numerator, which means this guy needs to be multiplied by a 2. This guy needs to be multiplied by an x minus 1. Okay, so then I can rewrite this as the limit as x approaches 3 of negative 6 plus 3x plus 3 times negative 1 gets me a minus 3 all over 2 times x minus 1 all over x minus 3. Alright, and then I'm going to save myself a little bit of work. I have the whiteboard. I'm going to put this over 1 and I'm going to multiply by the reciprocal right here. And then I'm going to erase that stuff in the bottom so I don't have all that extra stuff. Okay. I'm then going to simplify the top and hopefully something will cancel, and it should if I did everything correctly. I can factor out a 3 and it looks like I'm left with an x minus 3 because those made negative 9 all over 2 times x minus 1 times x minus 3, and exactly as we wanted, these guys cancel, and now I can direct substitute in 3, and I have the derivative at 3 is equal to 3 over 2 times when I plug 3 in gets me 2, or 3/4. Okay, so there's the derivative at the value 3, and that's using the definition of the derivative at a point. Alright, so we'll move on.